Okay, all right. Very good evening to everyone. Are you able to see the screen? Ramya Mohan Pindabram. Good evening to all. Are you able to see the screen? Okay, good. So let us begin today's session. This is going to be last session for this course, live tutorial session. At the end of the course, and this is going to be your last assignment. And after that, we will have the next revision session on 20th October, and then on 27th October you all have exam. So let us begin this session. And in this session there are many things have been covered, like this PWM, this analog and digital SVPWM analog and digital implementation. And then we have covered the magnetic aspects in PV grid integration. And then this cost estimation, all these things have been covered. So we will see all these things, and in subsequently we will solve the problems also. Earlier what we used to do, we used to solve the session at the end, but today we will solve some problems after completing one part. So let us begin with this space vector PWM generation. So this one is the discrete implementation, how you are going to implement in digital controller. So these are, so if you have gone through the lectures, so if you zoom it and then you can if you want to write the equation of TA, TB and TC, so this will corresponds to the mid value and then minimum maximum value and the equations, and these equations comes from this comes by the multiplying the factor TS upon VDC. So we all know that what PWM does, if you provide the reference signal, and if this carrier signal inbuilt or you provide externally, then this PWM provides pulse width modulated signal to the gate driver that will drive the switches of the power tonic converters. So this input of PWM is reference signal or modulated signal and carrier signals. So these are some of the expressions for this SPWM technique for digital implementation. And the algorithm, if you want to write, then you have to first calculate TA, TB, TC based on this previous slide. And then we have T max, that is maximum of TA, TB and TC. And then T minimum is minimum of TA, TB, TC. And T effective will be T maximum minus T minimum. And then T naught is TS minus T effective, and T offset is minus T minimum plus T naught by 2. Then you can calculate TA on, TB on, and TC on, and then load this compare resistor of timer. So one thing we have to keep in mind that for switches in each leg, you cannot directly give complementary pulse. We have to add blanking time, period time, so that both switches will be off for some time to avoid short circuit of DC bus. Now for analog implementation, here sir has shown about this dead time effect, means how you can implement the dead time between the switching of the of switches in each leg. So you have to provide some shifting in the carrier signals, and based on this control signal, you can get the pulses with this date time also. That will keep protecting the switch by short circuiting. So here, this advantage of a space vector PWM generation, that this the third harmonic is injected in SPWM, and this when you inject this third harmonic, it is not going to affect because it does not provide a rotating phasor, because it cancels out. If you multiply with 3, then it becomes 0. So if you see this blue curve, then with SPWM, we could not complete, it could not be complete track. So we add third harmonic, that is this one green shape, and resulted waveform will become this red one, and is now within this modulation dash. And this is the maximum limit of modulation. This gray curve, the gray line is the maximum limitation. So you can see that we are tracking this actual signal by injecting harmonic third harmonic wave, and we are at the same DC voltage signals. So in the normal SPWM, we are having this 100% range. Your reference wave should be within this modulation limits. But in SPWM, you can track beyond that about 140%. So we are getting extra range for SPWM by injecting this third harmonic. So this is the advantage of SVPWM. So sir has shown some code for and this simulation for how we are injecting third harmonic and how this shape will come. So let us see some problems based on this SVPWM technique. So in this first problem, in a sampling duration of 1 millisecond, Triplet harmonics means it is multiplication of multiplication of 3 with the fundamental term. Means we are having fundamental frequency 50 Hz. So if you multiply 3 and then 9, 12 like that. So it is 3 omega t. So in this first problem, here the sampling duration of 1 millisecond is given. The timings of 3 reference sinusoidal waves are observed as TA equal to 0.9 millisecond, TV equal to 0.2 millisecond, and TC equal to 0.4 millisecond. What will the time duration T effective for which the active vectors will be applied for 3-phase load? So we have seen the equations in the first slide. So we will use that equation. Yes. So T effective is this one. T max minus T min. So T effective timing duration for which the active vectors will be applied for 3-phase load. So it is T max minus T min. And T max is maximum of TA, TB, TC. So if you see, the maximum is 0.9 millisecond. And minimum value is 0.2 millisecond. So this timing duration will be 0.9 minus 0.2. It will be 0.7 millisecond. So this is the answer. So let us come to the next problem. So referring to the previous question, what is the timing duration of zero vector in this sampling duration? So zero vector timing duration will be T naught. And if you see this T naught expression, then that is sampling time minus effective time. So sampling time we are given with this. Sampling time is given as 1 millisecond. So it will be 1 millisecond minus, we have calculated this timing duration effective. So it is 0.7 millisecond. So it will come as 0.3 millisecond. So these are some problems, basic problems based on this SVPWM technique. Now coming to the next problem, referring to the previous problem, the value of time offset which has to be added to the timings TA, TV, and TC to generate the SVPWM, where TA on, TV on, and TC on is. In SVPWM, where third harmonic is present. So you have to see the output for SPVWM. I think this similar type of question is asked in the assignment problem also. Yes, we have to go through in detail of this SPPWM. So coming to this problem, so we are having this, we have to find this T offset. So T offset will be T offset will be TS minus T effective. Sorry, T offset is minus T minimum plus T naught upon 2. So if you see this T offset, that is minus T minimum plus T naught by 2. So T minimum is 0.2 millisecond plus 0.3 upon 2. So it will come as minus 0.05 millisecond. And the next question, for implementing a space vector PWM, which harmonic component needs to be added with the fundamental sign difference wave? And the options are a DC offset, a third harmonic component, a fifth harmonic component, a seventh harmonic component, a second harmonic component. You can type your answer in the chat box. We have just seen which harmonic component we add to the fundamental harmonic reference sign reference wave to increase the modulation range. You can type on the chat box. I think so. We have seen that we are adding third harmonic component with the fundamental sign reference wave. So the correct answer for this problem is B. Now coming to the next part. So in the next part, we are having this PV and sub microgrid interaction. And what do you mean by this sub microgrid? The sub microgrid, you can take an example of this campus microgrid or large community schools, and it includes various sources, things, and some bidirectional ports also. So in source port, we are having the sources, while in the sink port, we are having the loads. And in bidirectional port, you can take it as battery, where you have this power flow direction both sides. You are taking power from the battery also, and you are giving power to the battery for charging it also. Yes, correct. Be the correct answer for the previous question. And if you are having these so many components for this sub microgrid system, then you need to just check they are interacting properly or not. So what are can be the issues for this sub microgrid system? The issues can be they are having different types of sources. So you have to interface with the various type of converters, and then you are having multiple things, and there maybe these things can be AC or DC type of loads, and based on the loads, you have to check the type of this buses you have present in the system, and then you have to maintain this quality aspect also. You have to maintain the power quality in the system, and then we have a grid instancy issue. Grid extensibility issues means that you have to further extend your semi-grid system. Then how you can, whether this microgrid can be interfaced with the another semi-grid system or not, whether they are capable of handling the power exchange with the other sub-microgrid system or not. So let us see this the example case based on this integrated magnetic. So we are having this grid, and then we are having this double E cores which are connected like this way. So if you are setting the voltage through grid, then we are having this fixed T51 on dt through this core. And so this now if you connect another voltage source here, so this voltage source also fixable d5 by d2 on this core. And since this d51 upon dt will be decided by only one voltage source, therefore additional voltage source cannot be connected in this limb. So there will be only current source. So this current source will decide the MMF value, that is NI value. And this is the load where this power exchange happen. This voltage will be induced using the Faraday's law based on this rate of flux change, and this load will be heated through this voltage source and current source. If you draw the equivalent circuit, magnetic circuit for this for this uh, uh, for this core, then we are with that having connected different sources and loads. So it will this voltage source and this current source, voltage source will that will be here, and this current source that is connected in shunt way, and this again one voltage source is connected in series to act as a stabilizer, while this acts as shunt compensation. Now coming to the part of this another voltage source, another current source. So this another voltage source you can act as a series compensator. Means if this grid is not able to provide that much of voltage to this load, then you can having a series compensator and you can vary the voltage that you are being provided to the load. And this shunt compensator, with the help of shunt compensator, you can decide the power being driven to the load. So here I have noted some points. So this first point is that if you want to feed more current, then you can see V1 is fixed and load is demanding power. And current control source provides MMF which will drive the power into the load. So this is the current control source, and that acts some compensator, and this is voltage control source that acts as series compensator. So this voltage current control source can also supply power to the load, as you here you can see this in this diagram. So this flux chain d phi 2 upon dt is affecting the series source component, so it will act as a series compensator, while this d phi upon dt will act as shunt source component, so it will act as shunt compensator. Yes, here there will be 2 d phi upon dt because this flux rate is constant by this voltage source. While this current control source, you can change the current in this core, and you can having more power, or you can decide the power flow to this limb. The flux range is fixed by this voltage source. You cannot change the flux chain. And while this current source is deciding the NI value, that MF value. So this voltage source is deciding this flux rate value, and while this current control source deciding the MMF value. So you have to check miss both this having same this flux rate. So that's why they are connected in parallel. They don't have different flux rate chains. While this d5 upon d2 is connected in series because it having different flux rate chain. So you cannot add connect it parallel with d5 upon dt. So two sources cannot connect it, means two voltages you cannot connect parallelly. So here in magnetics also the same thing is applied here in that in different way. Like here this voltage source is deciding the flux rate. So the flux rate, so two voltage source having different flux rate, so you cannot connect it parallelly. While this current control source is deciding the MMF value, so you can connect parallelly with this voltage source. And whatever the extra power being is being needed, that can be fed through this current control source, and you can manipulate the power through this current control source, while this voltage source is deciding this flux rate, and that will set this voltage at this level. Mohan, is it okay? Are you able to get it or not? Mohanji Damaram? So is it okay? Are you able to get it or not? But your voice is not coming.
Sir, I got a doubt.
Yes.
Sir, this is why we need voltage control sources since the grid is having sufficient capacity to deliver whatever we require. So then why we need give this additional voltage source and working current source, sir?
So this voltage source means you may get. We will see it in the next slide. Like here, this voltage source will act as a series compensator. Means you have I think heard about of Statcom and DVR. In this distribution system, we use the Statcom and DVR. So in the same way, it is acting like that. Have you heard of a Statcom or DVR?
Yes, I heard about them, sir. That is in
Yeah,
the flex transmission line system, sir. Is it true or not, sir?
yeah. Sorry, yeah, you're correct. DS Statcom is distribution system, and a Statcom in this transmission system. So DS
Right.
Statcom and DVR, we are having this that we connect this series compensator that will be done by DS Statcom, while this sorry that DS Statcom is parallel source, parallel current control source that will act as a parallel shunt compensation, while this DVR will act as a series compensation. So the same way the same work is being done by this both type sources. If you
Right, sir.
want to if we want to go in detail of these things, so we have to uh, look more into this analysis of all these things.
No,
But
no, sir.
you can correlate with this DS Statcom and DVR.
Right, sir. Right, sir. Got it, sir.
So so now we are having this central in the central limb. We are having this another binding. So if you turn on this switch, then V will be 0 and this flux rate will be 0. So there will no flux inside this link. So the central core arm will vanish. So this is the concept of flux rate switch. Now, if you apply this concept of flux rate switch to the grid interaction, so we have seen the how we are applying the control of this inverter by this DQ reference frame with synchronous rotating reference frame. So this controller be applied in DC control domain, that is DQ domain, and based on this control, you can have various types of applications, like you can enable this MPPT perturb ISD reference from where you can inject the current, inject the power based on this MPPT, and you can set this unity power factor by setting this ISQ equal to 0. And you can also apply this harmonic application cancellation method to this control. And this is synchronization angle estimation being done through this line voltage. And this we have seen using this phase lock loop. So this one is the MPPT control being here being use this hill climbing method, and this is the block diagram for hill climbing method. And next coming to this whole MPPT and unity power factor, how you can combine in the basic control diagram for this inverter control. So in this ISD reference, you are giving this current reference of MPPT that is being tracked by this hill climbing method. So that MPPT, this will PV model is working on MPPT, and this will feed power according to this MPP maximum power point. And if you set ISQ reference equal to 0, then whatever the grid voltage, whatever the voltage across this converter, so the same, the current being fed through, the phase difference between the current and the voltage will be 0. So this Q component will become 0, and you can feed the power at unity power factor. So this is the example of series compensation. So here, if you see this one is grid voltage, now you can compensate this the another voltage control source using this converter, and you can see this voltage across load is sinusoidal. We have distorted voltage. We have distorted voltage. Whatever the voltage coming from the grid is distorted one. So we don't want the same distorted voltage appears across load. So utility always wants to feed power that is having a good power quality. Quality of power, quality of whatever the voltage being feed through the grid, utility always wants to having a good power quality given to these customers. So, but here see this grid voltage not sinusoidal. So the another way they have done is that using this converter, they are doing series compensation, and they are feeding this harmonic compensation, and this voltage appears across the load is sinusoidal. If load, we did not solve previous problem. Yes, we will solve previous problem. We have time. We have 1.5 hour. So if load is 40 kilowatt, then we should have transformer core to handle 40 kilowatt. Yeah, means based on your power rating, you have to decide this transformer core rating. You have to, in the design of this transformer core, you have to set the whatever the amount of power they can handle. So it is true. So here you can see this grid voltage being tracked, and this whatever the voltage being fed to this voltage control source is being also tracked, and we are having this reference wave is sinusoidal. So we want the voltage across load is of purely sinusoidal. So we are doing here series compensation for that. You can also solve it as voltage compensation. So this is the voltage across this winding 3 and winding 4. Now in this case, they have used the application of this flux rate switch operation. So when this so if you see this first one, then in this case it is a stabilizer mode. Means this acts voltage control source acts as a stabilizer, and this one is the grid voltage, and top one is the load voltage. And if you turn on this switch, then it will act as a UPS mode. Sorry, if you disconnect this grid, then this voltage control source will act as UPS mode. So only one voltage source will present in this core, and then this load voltage set by this source. And the inverse of this, initially it was in UPS mode, means it is only the source present The grid is not present in this case. While this, as you connect the grid, then we are having this voltage control source will act as a stabilizer mode. Now, in the next case, we are having shunt compensation. So this one is the grid voltage, but you can see that with the help of shunt compensation, we are checking the quality of current also. So the shunt compensation is also called as current compensation technique. And this, you can see this current is having good quality. So due to this shunt compensation, we are able to play with this current. While this, due to series compensation, we are able to play with the voltage. In UPS mode, flux switch is closed. So let us see. So if you close this switch, then this voltage across it will be zero. Means the central will not come into picture. Yes, in this UPS operation, this will be closed because this flux means both flux cannot be cancel. This flux, because two voltage source we have central limb, so it can having the flux rate is same in this side across the voltage. So if you having only one source, then you have to close this close the switch across the central limb. So that is the concept. If there is only one switch, then you need to close this central switch. So in you can say that in UPS mode, you have to close this switch of this central limb. Yes, that is true. This UPS mode, this flux switch be closed. So this is the, you can extend your this concept with this uh, you can have this multiple shunt compensation, and you can have multiple series compensation. So in this way, many micro cells can form a extensible network. So let us come to this problem from this part. So the first problem is that in an triple E core, in each limb there is winding as shown in the figure. Each winding is connected to a source, which of the following is correct regarding the sources. Number of turns of each winding is equal. Two can be voltage source and one can be current source. B option is all three can be voltage sources. C option is all three can be current sources with unequal magnitudes, and D option is cannot comment on the type of sources. Yes, it is true, Rajnikant, correct. So A option is correct. We have seen that two can be voltage source while one can be current source. Exactly, I have put here. So the answer is two can be voltage source and one can be current source. A is the correct answer, and the reason for this is that in double E core, if two voltage sources are connected to the two bindings of double E core, then D phi flux rate is already fixed in the third limb. So we cannot connect a voltage source in the third limb. Hence, a current source need to be connected to the third limb. Now coming to the next problem, in the magnetic circuit, given in the figure. Initially, the switch S was kept open. When the switch S is closed, then the current through the source V is. So, anyone can give the answer? Yes, I have correct. I have ticked the correct one. Two can be voltage source, one can be current source. Yes. When the switch is S is closed, then the current through this source will be increased. Yes, D is the correct answer. I think many of you have given the correct answer. Rajnikant, Ramya, Mayor Kegar. So let us come to the next problem. In a flux rate switch connected to the grid, where the grid is imposing the voltage source across the terminal in the figure, which are the following in the correct statement pertaining to the transformation of flux rate switch circuit into magnetic domain. And I have given you the hint here. So this is multiple slit question. More than one options are correct. So can you guess? So let us see the first option. The first option is that the voltage applied in the electrical domain is proportional to the flux rate, which is analogous to current in magnetic domain. So this voltage applied in electrical domain is proportional to the flux rate, which is analogous to the current in magnetic domain. So we have seen the equivalent circuit for this magnetic circuit part. So this is correct. While the second one, the voltage applied in the electrical domain is proportional to flux rate, which is analogous to mmf. So this will incorrect. While the third part, the current applied in the electrical domain is proportional to mmf, which is analogous to voltage in the magnetic domain. So this is the correct one. While this D option is current applied in electrical domain is proportional to flux rate, which is analogous to the voltage in magnetic domain. This is also incorrect. So A and C are correct option. The first one related to voltage control source, while this C option is related to current control source. So let us see the next part. So the next part we are having this costing of PV system. So in this part we will estimate the cost of, means whatever the cost present today is will be how it vary in the future, and if you know the future cost, how what is the present world. So here in this slide you can see that a item has a value given at this present time. So you need to transact with money. So for the money, it is related with the interest. So the money value will increase with the time, while this item value is also increased with time, and this is related to the inflation. So money related with interest, while this item related with inflation. And this interest and inflation have various growth profiles. So we can model it with different growth profiles. And there are three types of growth profiles. First one is linear growth. Second one is compound growth. that is also known as discrete compounding. The third one is exponential growth. It is also called as continuous compounding. So in linear growth, we are going to see this simple example of linear growth is simple interest. So we have gone through in high school, and before that also we know the simple interest expression. So if we are having this rate of interest is I, and then this number of time intervals that you can take delta t. So if you can write this, the value of money at 1 year will be S naught plus S naught I. So S naught is the present worth of money. So S naught 1 plus I, and you can similarly write S2. S2 will be S naught plus S naught into 2I. So it will be S naught plus 1 plus 2I. So you can write this sum after n intervals will be Sn is equal to S naught plus into 1 plus Ni. This is simple interest equation. Similarly, you can having this compound growth where we are going to use this compound interest method. In the compound interest method, this is the most typical and most of the bank and everywhere they are using this compound interest method. So this in this if nothing is given in the problem, then you have to use this compound interest method. If they are specified, they you have to use this simple interest or simple interest or exponential interest. Then then it is okay. Otherwise, you have to, if nothing is given, then you have to use this compound interest method. And this compound interest method expression will be Sn is equal to S naught into 1 plus I to the power n. And then we are having this exponential growth. In exponential growth, we are having in 1 year, they are having divided into m intervals. And if this m increases to infinity, then this expression will come Sn is equal to S naught into e to the power in. So if you summarize all these three, then they are having three expression. The first one is simple interest expression that comes under linear growth. So S naught into 1 plus Ni, while this compound interest comes under compound growth. So it will be S naught into 1 plus I into N, while this exponential growth is S naught into e to the power In. So this exponential growth is the easiest to remember, while this for compound growth and linear growth. So you remember this linear growth 1 plus Ni, and for compound growth this N will go up. So you can remember this compound interest expression also. So now coming to the problem. So I have solved some problems based on this part, and some problem we will solve later also. So here an amount of 1,40,000 is deposited in bank for a period of 27 years. Ratio of total sum of money acquired at end of interest period in case of compound interest to that of simple interest. So we are having this present amount of money is given 1,40,000, and this the period we have kept it 27 years, and the interest rate is given as 12%. So we have to find the ratio for the total money that will come after 27 years to the simple interest money. So first we will see the amount of money that will be acquired at the 27 at the end of 27 years will be this expression S naught into 1 plus Ni. So it will be 5,93,600. While with the compound interest, the amount will come as 29,85,483. So here you will get the ratio of this total sum acquired in the 27 years by different methods. Will be 5.029. So it is approximately equal to 5. So the correct answer is 5. So based on these different types of growth, based on different type of growth profiles, where we can see one example. So here interest rate is given as 5% per year, and n is varying, and we have taken this initial value is 1. So you can see this simple interest, its value will be 1.25, and for compound interest its value will be 1.2, and for exponential growth its value will 1.284. And if this n value increases, the value of money will value of price will also increase. And you can see this, if you compare all these three growth profiles, we are having this higher return is coming in the exponential growth. So as I said, this compound growth is used more practically. So we will consider this compound growth only. We will use this compound interest further only. So this money is related with this interest rate, while this item is related with the inflation rate. So whatever the value of money today is S naught, after n years, its value will be S naught into 1 plus I upon n. While this item bought, it is C naught. So this based on the inflation rate, its worth will be C naught into 1 plus F upon n. Now it should be same to purchase the item. So whatever the inflation rate and whatever the future worth of that item, such that we can having the same value of money today. So it should be same such that we can purchase the item, and such that we can save that money and we can purchase it at later period of time. So if you just equate these things, then you will get C naught into 1 plus F upon 1 plus I upon n. So it is present worth. So you have to save S naught amount today with interest I, so that you will be able to buy item in nth year having this inflation F. What is the use of present worth and why we are calculating? So present worth, you can means like, how you can say, you can estimate the, you can estimate means price, like means what amount of money you need today. You know the means like, if you have this amount of money, and you know the interest rate and inflation rate, then you know that what amount we have today, so that we can spend 10 years later. Now means suppose you have planned something to do in 5 years, and you want to start saving money from today. So you can you cannot save the money like in one day. So you are planning today means in 5 years you have some amount of money. Now later amount of time, you can see that after 5 years, can is I am able to invest that amount of money. So practically there are many examples like that. Based on the interest and inflation, you can decide your capability of investment. So it is a financial type of aspect. So there is nothing relation with this electrical engineering background. So you can use this type of case in present life also, means daily life use also, means purchasing of anything like you need some car, bike, what amount of money you need today, means you want to purchase 2 years later. So what amount of money you start saving, so that you can amount of money will be, so that you can buy it later. Now this example, an item cost 100 rupees today. So in order to buy that item 5 years from today, how much should one save or set aside today if interest rate is 8% or inflation rate is 5%? So it is a 100 rupees today cost, and he wants to buy that in 5 years onwards. So what amount of money he need today? So this you apply the previous expression, S naught equals C naught into 1 plus F into 1 plus I into N. So this is present worth factor, and this is present value of money, present value of the item 100. We will need 86.86 should be saved today. So the if based on this interest and inflation rate, this item cost is 100, but you need to save 86.86 rupees today to buy that item 5 years later. And if inflation rate is 0, then you need only 68 rupees to be saved today so that you can buy 5 years later the same item. Yes, this type of problem will be asked, and this is the I think the easiest one. You have to remember 2 or 3 expression only. I will tell what which expression you need to remember. Now coming to this annual payment and present worth factor. So we have seen the future value of money and present value of money. Now, as I said, you cannot save money in one day. Means like you have to plan. Means in each month we will in each year we will save this amount of money, so that at the end we will have that amount of money so that we can invest somewhere or we can have purchase something. So this is equal annual payments. We have divided equally in each year. So the equal annual payments, and since this the value of money at value of item at n years at the end of n years will be s naught into 1 plus I n, and this present value of item will be you have to divide by 1 plus I upon n. So this is the future worth. So you have to multiply with 1 plus I upon n. So that will be the future worth factor, while the present worth factor will be you have to divide by this 1 plus I upon n. Now this S naught, this S naught will be what? S naught will be you are having this equally annual payment. So S naught will be same as this B plus 1 plus I, so on. So this sum of n geometric progression will give this value S naught equal to D into 1 plus I into 1 minus 1 upon 1 plus I, and this is present worth factor. So this present worth of all future annual instrument taken together. So D amount of money you have just do payment each year. So what is the value of money today will be coming from this expression. So you have to keep this in mind. So this expression is very important. So it is written like that: if an atom cost S naught today, then one needs to pay early installment at interest rate of I, then this equal early installment will be S naught upon present worth factor. So you have purchased some item at the price of S naught, and you need to have the payment of yearly payment, and this interest is I. So what should be equal yearly installment? So it will come from this expression. And there are some problems based on this equation also. Now in the same case, we have considered the inflation rate also. An earlier part, we have not considered the inflation. So without inflation, the equation will coming like this, and with inflation, the equation will be something different. So these two expressions are very important. This one, without inflation, is not equal to D into 1 upon I into 1 minus 1 upon I plus upon N. So with inflation, the same you do simplification, then you will get this one expression. And where this interest is not equal to inflation rate, and if interest is equals to inflation rate, then this will be only this N. So it is the number of years you have to do the payment to just that you have purchased the present time, so that you can what amount of yearly payment you need to do. So if you see the previous one, So we can write without inflation also. So it is 1 upon I into 1 minus 1 plus IN. Right? This one I think. Yes. So this is simple. So this is without considering inflation, and this is without considering inflation, and this equation is with considering inflation. So just remember this inflation part, and this without inflation you can easily get. So without inflation you have to just remove this top numerator part, and here f will become 0. So from here you can also get, if we substitute f equal to 0, if you substitute f equals 0, then you will get s naught same. S naught equal to d into 1 upon I, 1 minus 1 upon 1 plus I upon n. So you have to remember this expression only. You don't need to remember two equations. So if you remember this expression, then you can get the expression without considering inflation also. So let us see some problems. So the first problem based on this part is that the present market rate of photovoltaic panel is rupees 21 watt peak. For purchasing 5 kilowatt PV panels, the equal yearly installment required to be paid in next 10 years is rupees. The interest is 12% and inflation rate is 5%. So this present market value is given as 21 rupees, and this panel we want to purchase of 5 kilowatt. So multiply with 5,000, so we'll get 1,05,000, and you want to have do yearly installment of in 10 years. So n will be 10 years and I is 10%. Inflation rate is interest rate is 12%, so it is 0.12, while inflation rate is 5%, it is 0.05. So the present worth factor will be 1 plus f upon 1 minus f into this one. So we'll get present worth factor 7.1325. So D, the yearly installment you got will be divided with present worth factor. So we'll get 14,721. So the correct answer for this problem is 40,721. So in the next problem, if the interest rate and inflation rate are same, that is 6%, the equal early installment required to be paid for next 10 years will be. So this here in this problem, this interest rate and inflation rate are same. So we have seen that if both are same, then this present worth factor will be equal to number of years. So this will equal to number of years, and number of years is given as 10. Therefore, this early installment will be S naught upon present worth factor. So it will be 10,500. So if you know how to use these two, if you know how to solve these two problems, you can solve many such type problems, and most of the problems are based on this equation only. So these two problems are, I can say these two problems are the most basic one, and if you know to solve these two problems, you can solve many problems. Now let us come to this life cycle cost. So this life cycle cost will having the several components, and the components are, it includes this capital cost, that is the initial investment, and then we are having replacement cost, whatever the item equipment you have you have installed, it needs to be replaced in some intervals of time. So it includes this replacement cost. So include and then we are having this maintenance cost. So we are having this annual maintenance charge something. So we will include this maintenance cost also in this life cycle cost, and then we have energy cost to run that item or to run that something equipment, and then we are having a scrap cost. A scrap cost is means after dismantling that component or equipment or a system, means the remaining things, whatever the value of that money, whatever the value of the item that you have dismantled. So the scrap cost is that one. So its LCC will be this capital cost plus replacement cost plus maintenance cost plus energy cost minus scrap cost. Why we have uh, subtracted this scrap cost? Because this amount of money you will get after dismantling uh, your something, your project or your whatever you have invested somewhere. So this will be nothing go where, means scrap cost will be always with you. So this scrap cost will be subtracted from this cost that we have to that we are using while running any system. So this capital cost plus replacement cost plus maintenance cost plus energy cost and minus the scrap cost. So this will be total life cycle cost for a certain thing. Now we have to calculate this life cycle cost for the PV based pumping system, which has the flung data, and this PV array plus base of system is having cost this one and life is this one, and so on. So this all this data, based on this data, you can make this on time axis, where this annual maintenance cost is having each year, and then this pipe replacement happen at some instant of time that is given in the problem. This pipe cost will be replaced after each 5 years, while this motor and pump replaced at each 7.5 years. So you can calculate this capital cost first, that initial investment, and then this replacement cost will be covered, will be used with this present worth of money. So present worth of money you have to multiply. If you know this value of this motor, then what should be the amount you need today. So so the present value of money should be multiplied with this present worth factor. So you will get this motor and pump replacement cost. Similarly, you can have this annual maintenance cost calculation, and then you get the LCC life cycle cost, and then we will get the annual LCC. Means annual LCC means each year what amount of money you want to have, you want to need to provide if you have taken that amount of money. So this will come as 8131.5. In the second example, we are having this community of 100 people and the source of water to be supplied from bore wells, and the data are given. So I want you to just go through this. I think you will able to understand it. If you don't able to understand, then you can ask in the discussion forum, and you can ask right now also. So this question is just looks lengthy, but you have to just see all the things. Start from this capital cost, how you can calculate capital cost. So capital cost is digging of 6 bore wells, and this replacement digging of 6 bore wells plus cost of 6 hand pumps, and replacement cost is calculated in this way, and maintenance cost, then LCC, annual LCC, and we have one problem based on this also. So in the earlier part, the density of water is considered as 1000 gram per meter cube. While in this part, the difference is only that density of water is considered 1028 gram per meter cube due to this various salts and heavy metals and independent temperature variation. So both the problems are same. You have to find this unit cost per liter of water for a life cycle of 20 years. So first made the time axis. Then in each year we have annual maintenance cost, and in each years we are having hand pump replacement because this lifespan of hand pump is 10 years, and this cost estimation has been done for 20 years. So it is written that for a life cycle of 20 years. So first we will find this capital cost. Capital cost includes this digging of 6 borewells and the cost of 6 hand pumps. So digging of 6 borewells. So the cost of each borewell is the cost per meter for digging the borewell is 250 rupees, while this borewell depth is 20 rupees. And there are 6 borewells, so it will get 30,000 rupees. And this cost of 6 hand pumps, so each hand pump cost is given as 5,000. So the cost of 6 hand pumps will be 30,000. Therefore, total capital cost is rupees 60,000. Now you have to find the replacement cost. So replacement cost 6 hand pumps to be replaced in the 10th year. So the value of hand pump is 5,000. Each hand pump is 5,000. So you have to multiply by 6 in order to calculate the 6 hand pump replacement cost. And this present watt factor is 1 plus I upon N. So multiplying this initial value of initial cost of this 6 hand pumps with present watt factor, you will get 11,566.30. Now how will find the maintenance cost? This annual maintenance charge is given as 1,250 rupees for each borewell. So for there are six hand pumps, so there will be 7,500 we annual maintenance cost. Now you have to calculate this present watt factor. So this present watt factor will 1 upon I into 1 minus 1 upon 1 plus I into 20. So you will get 8.514. Therefore, the maintenance cost will be 63,855. Now this life cycle cost will be K plus R plus M minus S. So S is 0. So therefore 1,30,421.29. And annual life cycle cost will be each year how much amount of money you will provide. So you will need. So it will be divided by watt factor. So it will be 15,905.72. Now to find the unit cost of water, you have to find this per year requirement in meter cube. So number of families 20, number of members per family is 5. So total number of people will be 100, and per day requirement will be 4,000 liter per day because per capita consumption of water is given as 40 liter per day. So per year requirement will be 4,365. It will be 14,60,000 liter per year. And you have to divide with density. So it will be coming meter cube per year. So it will be 1,420.23 meter cube per year. So unit cost of water will be annual life cycle cost upon Q. So annual life cycle cost will be this one, and this divided by this per year requirement of water is this one. So we will get 11.2 rupees per meter cube. And the third example, you have to find the break even point. The third example, you have to find the break even point in such that you have a PV system at a community level that is providing this power, while this power in another case this power is coming from this micro hydel project microhydel plant, and this distance is d kilometers. So what is the break even point such that means this microhydel plant investment and this PV system installation investment will be same. So you have to find the D. That means beyond that distance, this microhydel project will be expensive than this PV system installation. So just go through this and you will get D value as 28 kilometer. Means cost per kilowatt hour you will get for this microhydel plant is 1.67 plus 0.19 D, and this cost from this cost per kilowatt hour from this PV plant installation at the same community level you will get 7 rupees. Now if you just equate both of these thing, you will get D value is 28 kilometer. So the break even point is that 28 kilometer, and that means for distances less than 28 kilometer, this microhydel is economical, and if distance greater than 28 kilometer, a local PV plant is economical. Now coming to the next, coming to the last part, there are some problems we will solve, and then we will close today's session. So here this first problem that cost of solar panel is rupees 2 lakh. It is about an annual installment at an state rate of 8.5%. What is the annual installment to be paid in rupees if it is calculated with compound interest approach? So till here, anything you want to ask, any doubt? Calculating the replacement cost, what does it imply? Yes, replacement cost means you know the value of the item. You know the value of the item, and you know the interest rate. So what amount of money you need to have right now so that you can replace at some instant of time later. But inflation rate is not given in the problem. So you have to just use the interest rate only. So based on the interest rate, you have to find the replacement cost. That means what amount of money you need today so that you can use that means that value of money will increase later, and from that of money you can purchase that item. Compare capital cost with replacement cost. Yes, capital cost is rupees 60,000 and replacement cost is 11,566. In this only or this in break even point problem. What is the meaning of 11,566? Yeah, that what I'm saying you means you have this amount, this means how I can say, you know that at 10 year you have to, this 10th year you have to replace, you have to replace you have to replace the hand pumps, right? So hand pump cost right now, hand pump cost right now is 5,000 into 6. So that is 30,000. And that you can say it as C note, right? So S note is related with C note into this parent work factor 1 plus I upon N. So we have seen this one in the previous slide. Is it cost per replace 6 pump then is lower than 30? Yes, it is lower than 30,000 because we have not considered the inflation rate. In this problem, we have not considered inflation rate. That's why it is coming lesser. You got it or not? If you consider the inflation rate, then this value will be might be some closer or more than that amount of money. So you see this fundamental calculation for this money requirement. So this item cost is C naught, while this money value is S naught. And this money value is related with interest rate, while this item cost is related with inflation rate. But we have not considered the inflation rate. So we have not multiplied with 1 plus F upon N. So this only if you don't consider inflation rate, then right now based on the interest rate, this it means that the item value is not increasing. Item bought means item cost is 10,000 right now, and this later also it will be 10,000 only. If we consider inflation rate, this item price will increase, and so that you need large amount of money today so that you can increase, so that you can purchase that hand pump later with the higher amount of with the higher cost. Did you got, Mohan? I think from this example, from this diagram, you can clearly understand. Okay. The conclusion is that only we have not considered inflation cause inflation rate. We have not considered inflation rate. That's why this price is coming lower. If you have considered inflation rate, then 10,000 cost of something is not will be 10,000 later period time. It will having higher amount of money. So higher amount of higher cost of that item, so that you need to having higher amount of money to be saved today so that you can purchase later amount of time. So in this problem, S note is given as rupees 2 lakh. You have to find the it is about an annual installment and interest rate is given as 0.085. What is the annual installment to be paid with the compound interest approach? So if you make the time axis, I think something is mixed in this part. N value is given as 3 years. Today it is like 1 S naught and then D dt. So we know the relation is S naught equal to D upon I into 1 minus 1 upon 1 plus I upon N. So N value is 3 years. So this one is present worth factor. So if we substitute all this value, it is 2 lakh equal to D into 1 upon I 0.085 into 1 minus 1 upon 1.085 Q. So we will get 70,000 equal to D into 0.2171. So D is 78,308. So in 3 years, you have to give 78,308. Since interest is given, so if we sum up all these things, it will be more than 22 lakh rupees. This is the answer. Now let us see the next problem. PV array shall be installed for a domestic installation. Its capital cost is, let us write down the things they have provided. Its capital cost is rupees 1,50,000 and life of PV array is 30 years. Life span is 30 years. The annual maintenance cost is rupees 750 per year. Calculate the life cycle cost of the array. Consider the scrap cost. A scrap cost is given as rupees 10,000 at the end of its life, and an interest rate of 10% on maintenance charges. And this interest rate is given as 10% on the maintenance charge. So first we find the maintenance cost. So maintenance cost will be AMC into 1 upon 1 I into 1 minus 1 plus I upon N. So annual maintenance charge is 750 rupees. I is given as 0.1, 1 minus 1 upon 1, and N is given as 30. So it will come as 750 into 0.9427 upon 0.1, so it will be 7070.1. In order to calculate this maintenance cost today, its meaning is that means like your annual maintenance cost you are providing each year, this AMC. So you are providing each year. So it is 0 year and 1, 2. So it is till 30 years. So you have to find this M right now. So how you can find this M right now? So we know this relation is not equal to D into 1 upon I into 1 minus 1 plus I upon M. So we will use this relation and we will find this present cost. That is maintenance cost. So in this problem, they are asking this LCC. LCC is K plus R plus M minus K plus R plus M plus E minus S. So R is 0, E is 0, K is 1,50,000 and M is 7,700. Scrap cost is 10,000. So its value is coming as 1,47,007. Meaning if I save 770 today, I can have over 30 years AMC. Yes, it is true. If you have 770 today, I can cover 30 year AMC. That is true. Now coming to the next problem. Calculate the annual LCC of the solar panel discussed in the previous question. So annual LCC is LCC upon present worth. So this present worth we have already calculated. So this part is how much? Or you can say this part. This is 0. This is 9.427. So LCC we have 1,47,007 and this present worth factor is 9.427. So this is present worth factor. So ALC is annual life cycle cost. LCC upon P present worth factor. So it will be this one and you will get rupees 15,601. Now let us see the next problem. So in the next problem, this cost of solar heater is 25,000. So this S note is rupees 25,000 and then inflation rate of 6% and interest rate of so inflation rate is 0.06 and interest rate is 0.1. What is the present worth factor for n years following the compound interest model? The present worth factor for n equal to 3 that is 1 plus f into here both in inflation rate and this interest rate is given, so we will use this expression. So it will be 1.06 upon 0.04, 1 minus 1.06. So it is 1.06 upon 0.04 into 0.105, 2.787. This is the correct answer. So let us see the next problem. In the previous question, if the inflation rate and interest rate are same, what is the point worth factor following the compound interest model? I hope all of you can give the answer for this problem. You can write your answer chat box. I am giving the hint. The number of years is given 3. Does anyone know the answer for this problem? Ramya, Salini, Rajnikant, Mohan. Yes, 3. Very good, Chidambaram. Since inflation rate and interest rate are same, this present worth factor will be equal to number of years. Since interest rate and inflation rate are same, so present worth factor equal to n, and it is given as 3. So B is the correct answer. Now coming to the next problem. Here in this problem, it is similar to the previous one. We have solved one problem based on this same type. So here in this problem, the capital cost of PV array is given as rupees 2 lakh, and this lifespan is given as 25 years. The annual maintenance cost is given as 10,000 rupees per year. The scrap cost is given as rupees 10,000 at the end of its life, and an interest rate is given as 10% on maintenance charge. So this interest is given for annual maintenance charge. Calculate ignore the energy cost, calculate the maintenance cost. So it is asking about the maintenance cost first. So maintenance cost is AMC into 1 upon I, 1 minus 1 plus I upon N. So it is 1000. So it is 1 upon 0.1 minus 1 minus 1 upon 25. So it will give 9,777. So the correct answer is 9,077. B is the correct answer. If you have any doubt, you can stop me and you can ask your doubts. Calculate the life cycle cost of the PV area. So this is very simple. We have find this maintenance cost. So this is LCC. We know this A plus R plus M plus E minus S. Replacement cost is 0. This energy cost is 0. So K value is 2 lakh. We have calculated maintenance cost is 9,077 and this scrap cost is 10,000. So we will get 1,99,077 rupees. So A is the correct answer. Now let us come to the next problem. Calculate the capital cost of PV array is 2 lakh and the life of PV array is 20 years. Then I think we have solved this problem. No, it is asking about the present worth factor. Sorry. So it is asking about the present worth factor. So present worth factor is nothing. So present worth factor is this one. This one. So it is present worth factor and we have calculated value it's coming as 9.077 and the data are same. So this present worth factor is 9.077. So this is the correct answer. And this present worth factor expression is 1 upon I upon 1 minus 1 plus I to the power n. So this is the present worth factor expression if only interest rate is considered. Now coming to the next problem. The farmer borrows money from landlord for the irrigation system. Which of the growth models will prove to the most expensive for the farmer? And the options are simple growth, compound growth, discrete compound growth, exponential growth. So all of you give the answer for the problem. No, energy cost, that means not review generator PV panel. Energy cost, that means whatever the amount of power, amount of energy you need to require to run your system. Means like suppose your PV panel requires cleaning, so you have to some installation of water. You have to need some installation of how you can say water cleaning. Means the pipe, you have to set the pipe and you have to provide through this pump and you have can spread the water over the panel. So that includes energy cost. Energy cost did not means the revision. If it is revenue generated of PV panel, it should not be added. It should be subtracted. We are finding this life cycle cost. Life cycle cost means whatever the cost we need to install some system. And if some revenue generated, then it must be subtracted. It is not like that. We are estimating the system only. We are not dealing with this profit loss right now. Means we are uh, estimating the price and cost of a system. I think if you consider the profit loss, then you have to think about the revenue generation from the system. Please give the answer for this problem. A farmer borrows money from landlord for the system. Which of the growth model will be prove the most expensive for the farmer? Anyone? Yes, Mohan, you are correct. D is the correct answer. Rajnikant, you are correct. Exponential growth is the answer. So D is the correct answer for this problem. And this you can see for this in exponential growth, if you compare with simple and compound, then you can see this exponential growth having higher value of the money. So this is all for today's session. So if you have any doubts, any other thing you want to ask, you can ask me. Otherwise, we can stop today's session and we will meet on the next Sunday at the same time with the through the same link, and we will revise the assignment. So prepare well for your exam, and I suggest that just go through. I don't think you will get reminder note. This work will be done by the NPTEL people, and these are usually may I think they may give you reminder, but they should send a mail. I don't think they will give it or not, but hopefully you will get a mail. In the next session, we will do the revision of all the assignments, and I would suggest that you just go through the problems, because in the exam also they will ask problems, means the similar type problems you have solved in assignment. So if you have a score well in the till 12th number assignment, you are already I think 40% weightage from assignment or something more or less. Does anyone know what is the weightage for assignment? 30%.
25%. 25% will be calculated from best of 8 assignment out of 12, and 75% will be the calculated for the examination, which would be taken on 27th of October.
Okay. Yeah, miss 25% is very miss. You have good weightage. I hope hopefully you will get 80% or 90% from the assignment only. Means 20 marks from assignment part. So prepare well for your exam, and just it will be easier one only if you have gone through the assignment part. If you have solved your assignment carefully, and if you have not, if you have done mistake in assignment, just solve it again, and you will able to solve in the exam also. I think so. These things I don't know. I have given long before NPTEL exam. I think 3-4 years back. So at that time they are having the similar type of pattern. I don't know nowadays what they're asking.
Sir, I think there will be no negative marking for any question it is not mentioned. Am I right?
Yeah, no negative marking. It is correct. There will no negative marking, and MCQ, MSQ, they will ask, and this numerical answer type they will ask, because this same type will be asked, and this all question are of equal mark is correct. This all question having 1 mark weightage. They will not put more than that. I think so. I'm don't take it as a guarantee. I'm just whatever I have given exam long before, 3-4 years back. Based on that, I am telling. So you have to prepare all these things, and based on your whatever the given on portal, whatever given on this uh, course course portal, based on that you have to, that is confirmed only. Your whatever your things getting written, that is confirmed. And other things that are I am telling verbally, that is not confirmed. One can avoid cascade question. Yeah, but if options are given, then you can assume that you have done it mistake previously or not. Suppose in the previous problem you have given the wrong answer. So in the next problem, if there is cascaded one, if you are doing the wrong value, then you will not get the answer if the option is given. So from there you can assume that you have done some mistake. But yes, you can have this cascaded problem also, because in assignment there are so many cascaded problem. Okay, any other things?
No, sir. Thank you, sir.
Yeah. Okay, thank you all for attending the session, and I will provide the YouTube link and this lecture slide on the portal just within 1 hour, and we will meet on the next Sunday. Okay, thank you and good night.